Hello everybody, I'm going to present to you our work MOPED, a modular head-mounted display toolkit to conduct peripheral vision research. My name is Matthias Albrecht and I am from the University of Konstanz in Germany. Peripheral vision plays an essential role in human perception. For example, it influences our awareness of our environment, our personal safety and body posture. In fact, peripheral vision is the majority of the human visual field. Compared to central vision, peripheral vision is weak in distinguishing detail, but excels at discerning motion and contrast. Researching peripheral vision in AR and HCI is challenging due to the low field of view of commercially available AR HMDs. As such, specialized peripheral glasses have been developed. Peripheral cues have been proposed for notifications, public speaking, feedback, traffic navigation, preventing accidents for skiers and pedestrians, or guiding swimmers. The problem is that these devices were built for very specific applications and are difficult to repurpose. Many approaches solely use LED-based visual stimuli that are inherently limited in terms of what can be displayed. In addition, they often also do not feature any tracking, as it is necessary to render content that is aware of the user's head position and orientation. However, these works show that there are promising applications of peripheral visual cues and that there is an interest in researching these applications. That is why we built MOPED, the Modular Peripheral Display Toolkit. It is the first dedicated multi-purpose headset for peripheral vision research. It is reconfigurable and extendable to prototype peripheral vision interaction and visualization techniques. It features multiple display and tracking modules. MOPED focuses on exclusively augmenting the periphery, leaving the central vision free of obstructions. This is a promising concept for giving unobtrusive visual cues to the user without requiring an attention shift away from an important task like being in traffic. We feature multiple opaque and see-through LCD and LED display modules, as well as tracking modules for inside the lab and outside usage. Modules are attached to a 3D printed base frame. This allows us to create flexible configurations of the headset that can adapt to different applications and research questions. MOPED is built from off-the-shelf components that are readily available and easy to assemble. At the core is a Unity application which processes tracking data, drives LCD-based display modules, and controls the Arduino-based LED modules. The entire hardware and software is open source. We provide several samples and prefabs for you to create your own peripheral visualizations. To demonstrate the versatility of our system, we implemented several applications with peripheral visual cues. We are going to focus on two of them here, spatial awareness and balance. Check out the paper for more information about the other applications. Spatial awareness is a prerequisite for orientation in and interaction with the environment. It affects personal safety, for example, detecting fast approaching cars in traffic. Here, we visualize a tracked out-of-view object using peripheral cues. We make use of naturally existing visual event and object detection mechanisms to extend the perceivable human field of view. As the periphery is especially good in detecting motion and contrast, one can possibly relate the trajectory of the proxy on the displays to the movement of the actual physical object behind them. Peripheral vision contributes significantly to maintaining body posture and balance. Balance impairments caused by disease or aging often lead to an increased dependence on visual cues. This can result in falls when viewing a poor visual environment, such as when looking at a moving bus or a low contrasting scene. We propose a peripheral visual posture reference for balance impaired individuals. For example, tilting the head forward leads to a visual tilt backward of the bars on the peripheral displays, exactly like one would assume from real visual cues such as the outlines of a door or a cabinet. As part of a balance experiment, we conducted an initial usability study with 15 participants and found subjects were not irritated by the peripheral cues, and comfort is suitable for short-term experiments. In addition, we performed a heuristic checklist approach to evaluate our system. We concluded that Moped is more general and versatile than previous peripheral vision devices due to its modularity, which enables adaptability and flexibility. Moped allows for fast prototyping due to quick reconfiguration. Our selection of hardware and software components reduces the initial effort to decide which components are necessary and suitable for peripheral vision research. We also envision Moped as a tool for interdisciplinary research beyond AR and HCI. Peripheral spatial awareness cues could be useful for hearing impaired persons. Balance improvement using peripheral vision for elderly people could drastically reduce the risk of injuries caused by falls. Peripheral visual cues could also pose useful for individuals suffering from central vision loss, for example, caused by macular degeneration. Consequently, we think it is crucial to give researchers the necessary tools to create and evaluate such peripheral visual aids more easily. We want to talk about some limitations and future advancements. The size and shape of the current implementation of our headset makes it difficult to wear it together with another large AR headset like the Microsoft HoloLens 2. A combination of central and peripheral visual augmentation would be interesting to study in the future. A more compact and integrated solution with electronics and batteries could give greater flexibility without requiring a tethered connection to a PC. We also want to improve wearing comfort for longer periods of usage. An improved optical see-through design would improve viewing brightness and possible field of view. Moped is actively used for sports science balance experiments at the University of Constance. In the future, we want to evaluate specific use cases of peripheral visualization and interaction techniques, such as spatial awareness, in more detailed user studies to investigate their effectiveness and benefit. Thank you very much for your attention. You can check out our GitHub repository where you can find all information about Moped.